Isaac Newton's laws of motion. Introduction. Isaac Newton was an English physicist and mathematician and great repute. He was born in 1642 and died in 1726. He was an influential scientist who made several contributions to several fields, including mathematics and physics. One of his most notable contributions to the field of physics was the development of the laws of motion that were published in his book Principia. After the book's publication, the principles it contained guided the study of physics for more than 300 years and facilitated the creation of new scientific theories. The laws are still used today. The laws are very important in physics because they were used to form the foundation for the development of classical mechanics. They describe the relationship between an object and the forces that act on it to halt, increase, or initiate its motion. The laws have been explained and expressed in varied mathematical forms over the years. However, the principles of their application are fixed. The first law of motion. The first law of motion states that a stationary body or one that is moving at a constant speed will remain in that particular state as long as an external force is not applied to it. In case an external force is applied, a stationary body will start moving while a body that is moving at a constant speed will accelerate. This law is also used to describe inertia, which is defined as the tendency of a body to maintain a constant speed and direction by resisting changes in its state of motion when an external force is applied. The law holds that the net force acting on a body at rest is zero because there is no external force acting or the forces acting on the body cancel each other out. On the other hand, the force acting on a stationary body sets it in motion and increases its velocity. The second law of motion. Newton's second law of motion states that the total amount of external forces acting on a body can be computed by multiplying the mass of that body by its acceleration. This law is mathematically represented by the following formula: F equals m by a, where m represents the mass of the body and a, its acceleration. The law is only valid for physical systems whose mass remains constant and does not change over time. Newton's second law of motion is only applicable to constant mass systems because it does not account for changes in mass that occur to systems during motion. For that reason, many physicists have proposed certain changes to ensure that the law caters to both constant mass and variable mass systems. Certain systems lose or gain mass during motion. Therefore, the conclusion that the momentum of a body can be computed by multiplying its mass at rest with its velocity is erroneous because of the changes in mass that take place during motion. Newton's third law of motion. The third law of motion states that forces exist in pairs, and therefore, for every action force, there is a complementary component that acts in the opposite direction. This means that a body cannot be subjected to a single force without the existence of an equal force acting on it from the opposite direction. These two forces interact simultaneously and cannot exist independently. An example of the application of this law is observed in the firing of a gun. When a gun is fired, an action force propels the bullet forward, and a reaction force pushes the gun backward. Both forces are equal in magnitude and act in opposite directions. According to the third law of motion, action and reaction forces cause similar changes when bodies interact. For instance, if a body changes the motion of another body by exerting a certain amount of force upon its impact, it undergoes a similar change in motion that is similar to that exerted on the second body. Action and reaction forces cause similar changes in motion if bodies are not affected by other forces. Conclusion. The above-mentioned laws of motion were developed by Isaac Newton to describe how the motion of a body changes when a force of a certain magnitude is applied. The first law states that a body that is stationary or moving remains in that fixed state unless changed by an external force exerted upon it. The application of force to a stationary body sets it in motion while its application to a moving body increases its acceleration. The second law states that the net force of a body can be computed by multiplying its mass by its acceleration. Finally, the third law of motion states that forces exist in pairs, and thus, every force has a complementary component of equal magnitude that acts in the opposite direction. The aforementioned laws have played a significant role in the field of physics, especially with regard to new scientific discoveries.